Now today we are going to deal with one of the most important chapter, that is known as simple harmonic motion. So the thing is that why this chapter is important. Basically, in IIT syllabus, this chapter is so important because we are now in class 11. Now when you go to the class 12, then basically there is some kind of chapter in known as electrostatic. Then electrostatic discharge you perform simple harmonic motion. So at there you have to solve the problem using the concept of simple harmonic motion. And if you go to the magnetostat, so something oscillating kind of behavior, then you have to also solve it by simple harmonic motion. If you go to the fluid mechanics, in any portion you must have to use this concept. So this is very important chapter. And one of the most important thing is that without understanding this chapter we can't understand wave. And if you see in our surrounding, then in our surrounding lots of oscillatory motion are occurring. Like what I am speaking, my sound is coming in the form of some oscillatory kind of behavior. So without oscillation, nothing is possible. So around us, everywhere there is some kind of oscillation kind of thing. So this chapter is very important. So, and in IIT advance we are going to get a question. And most important thing is that this chapter doesn't contain some direct questions. You are going to get indirect questions. Suppose in fluid mechanics, they combine the simple harmonic motion with the help of fluid mechanics, and they are going to create the question. So this is a very important chapter. So now we will start. So at first we are going to define some basic terms. Then we are going to proceed further. So two basic terms we are going to define. At first we are going to analyze the motion. So first term in this is known as periodic motion. So at first we are going to understand what is periodic motion. So what is this? So periodic motion is a kind of motion in which basically the time period and path of the particle is going to be fixed. So like this. So it is a kind of motion. It is a kind of motion which it is path and time period is going to fix. So the path of the particle is going to fix, the time period will be fixed. For example, the motion of this is sun and this is earth. So the motion of earth around the sun is usually some like a circular kind of shape. This is around circular path. And always earth follow the circle path. And we know the time period. The time period of this is 365 days or 1 year. This is the time period. The path is, and so this is the fiction. And if you go to talk about path, the path is circular motion. So this is something called a periodic motion. Now there are a lot of examples like the motion of satellites, the motion of planets. These all are basically periodic motion because there are certain time and certain path. Now this is the here I define something. Here I have told about something about time period. At first we will understand what is time period. What is time period? So because this one you will encounter in this chapter regular interval. Because if you go to understand simple harmonic motion, then there is some kind of time period. So what is time period? So first thing is time period. So time period is basically minimum amount of time after that particle will repeat its position. So we can't take so everything is basically repeating. So after this time, the position, the velocity and acceleration, all the things of the particle is going to repeat. So this is that time. So if you want to define this term mathematically, suppose here we have seen the motion is circular. So suppose this is a position of particle at some time t. So this will go and come after completing a time that t, it will again come back to this position. So if you are going to define this term mathematically, then it is nothing but s t plus t. After t time, it will repeat its position. So this time, this is not a time period. So we can also define this. We can also define this as This is basically the minimum time after which particle repeats position. Okay, so and another term we are going to see in this interval is the element frequency. So this is artificially rotating around the sun. So we know about frequency. Frequency is nothing but frequency defined as 1/time. So frequency quantify one thing, that is suppose earth is rotating around the sun. Then suppose a particle is rotating around anything. Then how much rotation it will performing in 1 second. So it is a frequency that is defined as number of revolution per second. Suppose one particle is basically moving 5 times in 1 second. That means that its frequency is equal to 5 revolutions per second. Now if you talk about SI unit, if you talk about SI unit, then the SI unit of this is nothing but a hertz, or we can sometimes call it cycle per second. So this is frequency, this is time period. These are two basic terms. Now our main aim is to go to what? Oscillatory motion. What is that? What is basically the oscillatory motion? So now we are going to deal with oscillatory motion. At first we will understand oscillatory motion. After that we will differentiate between periodic motion and oscillatory motion. So what is oscillatory motion? Oscillatory motion is something kind of to and fro motion about a fixed point. That fixed point we are going to more importance to that fixed point. Because fixed point is sometimes we call this fixed point as mean position or equivalent position. So the fixed point is very important. So what is this? So oscillatory motion is to and fro motion. To and fro motion of a particle about a fixed point. So if I give you some example, suppose we have something kind of this kind of spring, and this is mass and attached to this spring, and if we stretch this spring a little amount of x, then the particle perform oscillating motion over this point. One of the misconceptions in this concept of oscillatory motion is that people think that suppose a particle is performing some oscillating motion around this position. One particle is going this and coming this. So one of the most major misconception is that the extremum, suppose this point is known as extremum, one particle going at that position, after that it is turning back. So extremum should not be necessary to be fixed. So extremum condition is not necessary to be fixed. In oscillatory motion, when we proceed further in this chapter, then we are going to learn about something called as damped oscillation. In damped oscillation, we are not going to see the trajectory to be fixed. It will start decreasing with the time. In damped oscillation, we are going to see that it will be like some kind of thing. It will basically start decreasing. So the path will remain fixed only in that condition where the total mechanical energy of the system is going to conserve. If total mechanical energy of system is not going to conserve, then the path will not be fixed. Path will stay like, but it will start decaying with the time. So if the path is fixed and time is also fixed, then in that scenario, this oscillatory motion is known as simple harmonic motion. Suppose this is plus A and this is minus A. We are going to define this what is plus A and minus A the next point. And this is some fixed point. We are going to see this fixed point in mean position. So particle is performing simple harmonic motion between this, and one most important thing is total mechanical energy will be conserved. So there is no leaking any kind of resistance force. So this kind of motion is said to be periodic motion. This oscillating motion is a kind of periodic motion. Now, one of the most important things, now our aim is to now understand what is the condition for oscillatory motion, because particle is not going to perform oscillatory motion in all the cases. There are some certain kind of rules and regulations to follow the oscillatory motion. So at first we are going to quantify this mean position. What is mean position? So in work power energy we have read about this term many times. This mean position only. So there are a lot of names of this term. This term is also known equilibrium position. Or this is also known as mean position. This is equilibrium position or mean position, or sometimes we call this position as a, if you read in SC book, then the right this term is center of oscillation. Okay. Now what is this equilibrium position? We learn in work power energy what is equilibrium. So at first what is equilibrium? So equilibrium is nothing but so in work power energy or in mechanics, basically simple harmonic motion is that chapter which requires a lot of concepts of mechanics. Without understanding of kinematic dynamics and work power energy, circular motion, you are not going to understand this chapter. So there are lots of prerequisites to understand this chapter. One thing is that at first we have to understand what is equilibrium. Equilibrium is basically a point. Equilibrium is basically a condition. There are two types of equilibrium. One is basically called as linear equilibrium, or second is basically rotational equilibrium. So if a particle is said to be equilibrium if it satisfies both the conditions, it is rotational equilibrium as well as also in linear equilibrium. So the thing is that condition for linear equilibrium is net force on the particle must be zero, and for angular equilibrium net torque must be zero. These are the two conditions. If these two conditions is going to satisfy, then the particle is going to linear equilibrium. So this is the condition. Now we read in work power energy also we can classify this equilibrium as three terms. First is nothing but stable equilibrium, and second is unstable, and third is neutral. Now our main focus is that if you displace the particle from any of these conditions, then particle is going to perform oscillating motion. No, the particle is going to perform oscillating motion only in that scenario when we are going to displace the particle from a stable equilibrium. You know the plot of this condition. So if the particle is stable equilibrium, then you have this kind of plot. If it is unstable, then it is some kind of plot. If it is neutral, then it is like this. So see that if the particle is there, and if you displace the particle a little bit from here, then particle is going to come back to its path and start performing oscillating motion. But in that scenario, if I am going to displace the particle is not going to come back. So this is not the case of oscillating motion. Because in oscillating motion, the particle should repeat its position. So for repeating its position, it has to come towards mean position. Okay. So in neutral equilibrium, suppose the particle is there, if you displace this, then particle is not going to come back. So in unstable equilibrium, neutral equilibrium, in this both scenario, we are not going to get any kind of oscillating motion. So motion will be oscillating only in the case of stable equilibrium position. So this is the main important condition for a particle to be in oscillating motion. So now we are going to learn about what is stable equilibrium. Some kind of mathematical thing we have seen that. So